Alright, so we're going to take a look at the 6 types of chemical reactions. This video gets to be a little bit too long if I do all 6 in one part, so we're going to do 3 parts. So in the first part, we're going to be looking at synthesis and decomposition reactions. So all in all, there are 6 types of reactions. This first part, we're going to talk about the first 2, synthesis and decomposition. So synthesis and decomposition reactions are the reverse of one another. So they're the same general reaction, just going in opposite directions. So in our synthesis reaction here, we've got individual elements, magnesium and chlorine, over here on the reactant side. And the right-hand side of the arrow, that is called our product side. So on the reactant side, we've got individual elements, and on the product side, we take those individual elements and we put them together to form a compound. So in this compound, we have magnesium, which is 2+, and we've got chlorine, which is 1-. So every time we create a new compound in a chemical reaction, we have to do a new drop and swap or crossover rule. So that 2 drops down there and becomes a subscript for chlorine. That 1- drops down and becomes a subscript for magnesium, but we don't write 1s, but we do write 2s. So we're going to write that in there. Now you may have noticed this 2 over here, it has nothing to do with that 2 right there. Remember that that 2 comes from that 2+ in the magnesium. This 2 is just because chlorine is one of the 7 diatomic molecules, and when it's not in a compound with anything else, it hangs out in pairs, or Cl2. So I'll talk about the diatomic molecules in another video, so make sure you check that one out. Alright, so that's pretty much it. We've got single elements combining to form a compound in a synthesis reaction. So the other thing we have to know how to do is we have to be able to balance. You will have noticed that on the class Facebook page, I have linked to the Khan Academy video on balancing. So if you're stumped on that and you need another point of view, please check it out, because I find them to be quite helpful. So when we're balancing, we have to have the same number of each atom of each element on either side of the equation arrow. So on the left-hand side of our arrow, we have 1 magnesium. On the right-hand side of our arrow, we have 1 magnesium. So on the product side, there's 1. Okay, remember that 2 right here doesn't apply to magnesium. It only applies to chlorine. So we've really only got 1 here. So we could, for all intents and purposes, write a 1 there and a 1 there, just so we know that that keeps our magnesiums in check. Then we can look at our chlorines. So this 2 right there, that applies to that chlorine. So that means we have 2 chlorines on the left-hand side of the arrow. This 2 right here means that we have 2 chlorines on the right-hand side of the arrow. So we've got 2 chlorines on both sides of the arrow. So this chemical equation comes pre-balanced for us. So that's really nice when that happens. It doesn't happen all that often, but it's good when it does. So the only thing we can change when we're balancing is these coefficients out in front. You don't normally write 1s in, but it does help you keep track. And remember, on your multiple choice exam, the way that those questions are asked is it asks you for the ordered coefficients for a balanced equation. So the answer for this one in the multiple choice would be 1, 1, 1. I'll definitely show you those and what they look like in class. Alright, so synthesis reactions, 2 individual elements combine to form a compound. Now, our second type of chemical reaction is called a decomposition reaction, and it is the exact reverse process of the synthesis reaction. So in a decomposition reaction, we have a compound on the reactant side, and we have elements on the product side. So the 2 elements involved here are lithium and fluoride. So we just take those 2 elements, split them up with a plus sign, and those are the products of our decomposition reaction. Now fluorine is, again, one of those diatomic molecules. So just like chlorine, when it's alone, it hangs out with a partner. And that's pretty much it. So we take our compound and we break it down into its individual elements. Now to balance this one, we've got lithium and we've got fluorine on the reactant side, and we've got lithium, and we've got fluorine on the product side. So in this case, we've got 2 fluorines over here. We've only got one of them out here. So we've got 2 here. We've got 1 here, so we've got to fix that. So we've got to put a multiplier out in front to make that 2. So 2 times fluorine is 2 fluorines. So that equals 2. So now our fluorines are balanced. But when we put a number out in front, that also applies to the other elements in the compound. So that means we now have 2 lithiums on the left-hand side as well. So we have to put another coefficient out in front to balance the lithium out. So now that we put that 2 out in front there, we also have 2 lithiums. So that's how we balance that one, and it's a pretty straightforward one. So decomposition reaction, we take a compound and it breaks down into 2 individual elements on the product side. So remember, synthesis and decomposition reactions are the same thing, just moving in opposite direction. So that's it for part 1 of chemical reactions, your synthesis reactions and your decomposition. I hope it helps.